graph is made up of collection of points and lines. Now each point is known as a node, or we can call it a vertex also. And each line is called an arc. We can also call it an edge. So arc or edge. It is possible that an arc or edge will have a value. In that case, we call the graph a weighted graph. A weighted graph will have specific values for each edge. A weighted graph is also known as a network. Every node has a number of arcs or edges attached to it, and by looking at it we will know what is the order or what is the valence of that particular node. For example, if a node has 3 lines attached to it, so here is 1, 2, 3, we will say that this node is odd. Again, this node has 4 lines attached to it, so 1, 2, 3, 4, we will say that this particular node is even. If we have one graph that where every particular node is they have even number of arcs connected to that, we will call that a Eulerian graph, where each node has an even order. For a graph to be traversable, it means if you take a pen and put it on every node, you should be able to connect the node and return to the original node without having to remove the pen from the paper. So, to traverse a graph is to go over every arc once and return to the original node. But there is a special condition for a graph to be traversable. That graph has to be an Eulerian graph. That means every node of that graph has to have even number of arcs attached to it. If that's not the case, then the graph will not be traversable. Here is an example of an Eulerian graph. Every node has even number of arcs attached to it. So let's try to traverse it. So the idea is to take the pen and return to the original node without taking the pen off the paper. So here goes. So we start over here, then go to here, then here, then here, and we can return to the original node. So we have traversed this Eulerian graph. Unless they specifically mention which node to start from, it doesn't really matter in an Eulerian graph where you start. You can start from any node. All you have to do is return to that node as you traverse through each and every arc of the Eulerian graph.